Okay, let's carry on our discussion on divide and conquer. So we were doing some geometrical problems, and first problem we were looking at was closest pair problem. So what was it? You are given n points in two-dimensional space, given their x coordinate, y coordinate, and what we are interested in is finding a pair of points with the closest distance, minimum distance, right? And there were a few ideas we were discussing. So one approach is via this divide and convert. So we divide the point based on their x coordinate, right? So you sort the points according to their x coordinate, find them and draw a vertical line through this diagram. And so divide the point into half, right? Let's call this two sets T1 and T2, and then we recursively find the closest distance in P1, let's call that P1, and find the closest distance in P2, let's call that delta T. And then we found the minimum of these, let's call that delta, but delta may not necessarily be the minimum distance, right? Because there might be one point in this half, another point in that half, so the distance between them is lesser than this delta. So we needed to check this condition. So what we did was that we considered a small strip of distance delta I. So this is was a rectangular strip, okay? And then we looked at points only within this strip, okay? And so then one idea was that we consider all possible points here, all possible points here, all possible pair of points. One is in this half, other is in this half, okay? And then look at the distance between them. But the problem was that there could be many points inside this script and very few outside. So that would have taken square time. So overall, the recursion would be Tn equal to 2Tn by 2 plus big O of n square. And that solution came out to be big O of n square. This obviously didn't work, and we had to do something clever. So what did we do? Then our next idea was, okay, we have this huge strip of distance delta on either side. So we divide into squares of delta by 2. And what was the logic behind this square? You wanted to say that all these squares can contain at most one point. And what was the reason? If there were two or more points,
Excuse me,
the
sir.
length would, yeah.
Sir, your voice is breaking sometime.
Oh, okay. It should be fine now. Yeah. So we had these strips of we had the squares of length delta by 2. Okay. And then we picked any 2 points inside the squares and look at the maximum distance between these 2 points. So that came out to be square root 2 by 2 delta, which is always less than delta. Okay. And so you cannot have two different points in this square. So because all of these are in the right half and all these points are in the left half, and we said that the minimum distance between those 2 points in the left half or right half is always less than or greater than equal to delta. So we always had one point inside this. Now pick some point here, and we said that we don't need to compare it with all points in this half. You just need to check the neighboring squares, right? And there are only a constant number of squares here, so you only need to check for each point for a constant number of points, and there are in all n many points, so you just need to check for O of n many points. And by the way, we also assume that the distance can be computed in constant time, right? Do you know how to compute the distance between 2 points in two-dimensional space, right? Okay. And one thing I should mention that we first sorted these points according to y coordinate, so that you can easily check whether the neighboring squares have a point or not. So yeah, what was the time complexity of this algorithm? Tell me. So the problem is it is not n log n currently. Okay. And why is not that? Because we did this divide step, we divide into two parts, right? And then we sorted these points according to the y coordinate, right? So how much time does sorting take? N log n. So finally, your recursion will be Tn equal to 2Tn by 2 plus n log n. And you solve that recursion and you'll get n log n squared, right? This is the main problem. So we are getting an extra term of log n here. So yeah, any ideas? How can we make it n log n instead of n log n squared? Uh, in starting, yeah, in starting we sort with respect to x-axis, then we divided it, and then in the strip we sorted with respect to y-axis. So there we had over a term of n log n, and total running time is n log n whole square, or n into log n square. So how do you get rid of this extra log n term? Yes, same problem. Same problem. You make strip after sorting it with respect to y-axis. No, no, you make a strip first and then sort the points in the strip with respect to y-axis. But the sorting takes n log n time, and that's the main problem. Overall complexity is n log n squared. So in fact, you need to do something clever to reduce it from n log n squared to n log n, which is that some of you might have noticed that we are doing the sorting by y coordinate later after creating this trip. Okay. So you can push it to the starting. At the starting, we are just sorting with respect to x coordinate. You also sort with respect to y coordinate. Okay. So that n log n is anyway going to positive. And then everything else we are doing in this trip, which is what? Compare it with constant number of points, that is all linear time. Then you can proceed with your recursive thing. Tn equal to 2tn by 2 plus we go up. So it's just pushing back and forth some steps. Okay, there's nothing much in it. And that is the way you reduce it to n log. Okay. So this is what you do. Initially, you sort with respect to x coordinate as well as y coordinate. Then xy is the points in the strip sorted with respect to y coordinate. For each such point, you compute its distance to the next 15 or whatever constant number of points in sy and keep track of the minimum. And that is your return delta 1, 2. And then you just put minimum of delta 1, delta 2, and delta 1. So this works in order of n time. But at the start, the
Sir,
sorting will be order of n log. Yeah.
sir, sir, your voice is actually breaking too much. We can't hear anything.
Yes, sir.
Okay. Let me try something else then. So I'll just move to another system. Be better. Yeah, trying some new system. You are facing problems here. Right? Or is it okay now?
No, sir. Still breaking.
Yeah. Let me just give me 5 minutes. I'll take this. Okay. So is it okay now? Yes.
Yes.
Okay. So let's continue. So we had this n log n squared time, and we want to reduce it to n log n, right? And our idea was to push this sorting by y coordinate to the beginning of the algorithm. So is it clear how we got n log n squared? We divided it into two halves, right? Those points. And after that, we created a strip and arranged the points in increasing order of y coordinate. And that step took n log n time. And when you solve this recursion, you get n log n squared. And the question was, how can we drop it down to n log n? Okay. So now our idea is to shift this sorting by y coordinate to the beginning of algorithm. In the beginning, we were just sorting by x coordinate. Now we also want to sort by y coordinate. Okay. And that's the thing here. So it looks complicated, this new algorithm, but it kind of works out. Okay. So you can I'll just quickly run through this algorithm, but you get the main idea. We are just pushing the sorting by y coordinate step at the starting of the algorithm. Okay. So you construct this tx and ty. So what is Px and Py? Yeah, Px is the sorted list of the set of points in x direction. Py is the sorted list of points in the y direction. And these two will take n log n time overall. And the rest of the computations you can do in big O of n time. So Q is the first n by 2 points in Px, right? Once you have the sorted list, you can find the first n by 2 points in big O of n time. And R is the remaining n by 2 points in the Px. Okay. And that also you can do in big O of n time. Qx is the set of points sorted in x direction. Qx, Qy, Rx, Ry. So these are defined. Qy is the set of points in Q in y direction. Rx is the set of points in R in x direction. Ry is the set of points in R in y direction. So all these things you can do in big O of n. Okay. So we constructed all these sets you can do in big O of n time. Then there is some dividing and conquering thing, right? So you recursively find the closest pair between Qx and Qy, Rx and Ry, and find the minimum of these. The rest of the algorithm is already what we discussed. We created this strip. S is that strip. It is the points in P within a distance of N. And we construct this Sy, right? Because we did that pre-computation where we computed all those points, this you can do in big O of n time. Compute the distance to the next constant number of points in Sy and let P1, P2 be the pair that gives the minimum. So that was our delta 1, 2. Okay. And just return the set of points. Okay. And this is the way you reduce it from n log n squared to n log n. Okay. So any questions so far? Otherwise, we move on to the next problem. So I also wanted to discuss the idea which we had last time. Chirag had the idea that why don't we construct some circles around every point? So Chirag, did you think about it or you are still thinking about it?
Good morning, sir.
Yeah.
I have not think about that further. I'm just thinking.
Okay. So I did think about it, and so I noticed some problems with that. Okay.
Okay.
First is obviously I don't see so. So my guess about your idea is that you construct circles around each point, and obviously you need to. So there are these n many points, and you construct n circles here. Okay. The thing is that you don't know the radius, so I'm assuming that you randomly pick some 2 points and compute the distance between them, and that will be the diameter of your or the radius of your circle. Okay. So it will contain at least 1 point, and then you just drop the radius by half and do something. But first thing is, how will you input a circle to the computer? Right? So you need some good way of representing a circle. And another point is, how will you decide if a point is contained within that circle? So these are the two main issues.
Yeah, sir. Just we have to think about that.
Yeah. So the first main issue I will try to address in the next problem which we had. So I'm not considering a circle now. So this is the new problem called convex hull. You may have already encountered this. So again, the same thing, a set of n points in the plane xi, yi, and we want to find the smallest polygon containing all points in P. Okay. So you are given this set of points in the two-dimensional space and you want to construct a closed figure. So this is not a circle, but it's close to a circle, except that it's not curved. So if you have a polygon containing thousands of points and length of each side is just 1 centimeter, then it becomes very close to a circle. Okay. So my first question is, how will you represent this polygon? Right? You have this polygon. How will you give it as input to the computer? What data structure are you going to use? Yeah, circular linked list. That's what was written below. So you have these points A, B, C, D, E, F, and you just put in directions, and A links to F, F links to E, E links to D, D links to C, C links to B, B links to A. Okay. So good, that's issue is sorted, and let's just first see the brute force algorithm for this. Okay. So how will you brute force here? So you consider every pair of points, right? So how many pairs are there? N squared. Okay. Construct this polygon and check whether all the points are contained inside that polygon. So the main idea you have to use, you are given a line segment and you want to check whether a point is on the left side or the right side of that polygon. So how are you going to check this? Even before that, what is the main difference which is common to all points which are inside the polygon and which are outside? Okay. Or let's just talk within this segment CD. So all the points inside are on the right side of this segment CD, and these points are outside. Okay. So how will you check whether a point is on the right side or left side of this segment CD? So you have to recall some trigonometry here, which maybe you have seen in school already. And so notice that if these points are on the right side, these points will be from C to this point to this point. It is going in anti-clockwise direction. And those points which are on the left side, let's say C to this point, they'll be going in clockwise direction. Okay. And you need to check whether these points are in anti-clockwise or clockwise direction. So how are you going to check that? That is the first question. Firstly, if you can recall, if you want to compute the angle between two vectors, you'll always consider it anti-clockwise direction. Okay. And the thing is, the angle between, let's say, this point, which is on the right of this segment, CD, and this angle will always be between 0 and 90 degrees. And if we are considering this point, then it's the big circle, okay? And that angle will be something between 270 and 360 degrees. Okay? And so it's standard in trigonometry that if theta is between 0 and 90 degrees, then sine theta will be positive. And if theta is between 270 and 360 degrees, then sine theta will be negative. So somehow we want to bring this sine theta into picture. And what is a natural operation for that? Remember, if you remember. Should we use the dot product or cross product of these vectors?
Sir, suppose,
So, yeah.
hello. So suppose
Yes.
that point name we P or
Okay.
any name like P.
Okay.
So
Okay. Yeah.
we have two vectors like CP and PD,
Yeah.
and then we can cross product of CP cross PD. Then we can get
Yeah.
other
Yeah.
vector which is obviously in downward or
Yeah.
upward.
Yeah. In downward.
So
Or
plus J or plus
yeah.
sorry plus K or minus K we can get.
Yeah. Yeah. Sure. Yeah. That's exactly the idea. We will take the cross product of these two. So yeah, exactly. That's
Yeah.
the
So
idea. So
if
you have
it
to.
is yeah. So if it is plus, then we can say that it is in the right direction of CD,
Yeah. Yeah.
or it is giving an anti-clockwise direction.
Negative. Yeah. Sure. Yeah.
Yeah,
So
negative then
yeah.
this clockwise.
Yeah. Very good. So this is what exactly we will be doing. And this cross product, how much time will it take? It takes constant time, right? So you just need to use the formula for cross product of two vectors. It's some you have to do some constant number of additions, constant number of multiplications, and you'll find that. So the trivial approach it is taking, we take n square many points for each point, we make order of n computations, and that will take overall order of n cube time. Can we use basic coordinate geometry to determine two points are on the same side of the line and other will be the one we want to consider? What do you mean basic coordinate geometry? Sorry, I don't understand what you're trying to say here.
Sir,
Yeah,
sir, here we have coordinates of 2 points, CD, and we have to find uh, given point is in which side of
yeah,
the
yeah,
line passes
yeah,
through CD. So,
yeah,
sir, using coordinates of C and D, we can define line equation of line,
yeah.
and if we put x and y coordinates of any point in that equation, uh,
Okay.
so we can find which point is in which side.
So how do you decide which point is on which side? So you put the value of x and y in the equation of this line.
Sorry, sir, what did you say?
So your idea is that you find the equation of this line connecting C and D,
Yes, sir.
right? And then you put the x and y coordinate of this point in this equation.
Yes, sir.
And then how will you know that this point is on the right side? So
Sir, this point is in right side. It cannot be determined. But if we are given 2 points, then we can say that 2 points are in same side,
same
that
side,
is,
yeah. So
or
that is,
different side.
yeah. Yeah, so that is using that idea of cross product. Using cross product, you can determine if all points are on one side and there is nothing outside this polygon. Right? Notice all these points are on the same side of each of these line segments. And that's what we want to check. All other points are on one side of the segment. So big O of n cube, obviously you want to do better. What do you guess? What will be the best running time of this variable? Can we do better than n cube? Oh no, so I confused with your idea. So this is not true. If y is less than mx plus b, they are on different sides.
Sir,
Okay, so
hello.
this is not true. Yeah. So you add this equation of the line y equal to mx plus b. You can't just substitute the x and y coordinates and decide. Okay. So the thing is that you need to use the property of these points which are on the right side. They are making some angle, counterclockwise angle if you draw the points to this. And therefore you have to go via cross product. So I don't have a counter example for your claim right now, but it is not too difficult to see that this is not. The only thing I know at least is via this cross product. Okay. So that idea might work for some x equal to 0 or y equal to 0, where you're just considering the x-axis or y-axis. But in general, it's not. So, okay, anyways, let's move forward. We have seen this naive algorithm which works in n-cube type. We want to use divide and conquer to solve this problem. Okay, we divide the set of points into two different sets, draw some line through the center, consider the median of these points according to x coordinate, and then you have two sets of points here, S1 and S2. You compute the convex hull of points in this set, convex hull of points in this set. Okay. And then you want to merge these two convex hulls to get a new convex hull, a polygon, which contains all these points. Okay. So this is our idea. We divide the points into two sets, P1 and P2, which consists of roughly equal number of points on both sides. Compute the convex hull of P1, compute the convex hull of P2, and just merge these two convex hulls to get the new convex. And how do you merge? So let's say I had this convex hull here, I had this convex hull here, and I want to merge these two convex hulls to get a new convex hull. Okay. So the obvious idea is you construct this upper tangent, okay, which are connecting these 2 points at the highest y coordinate. And you construct this lower tangent, which is connecting these points at the lowest y coordinate. Okay. And then using this lower tangent, upper tangent, and connect some points here, you'll get the new convex. Okay. So how do you find this upper tangent and lower tangent? That's the main issue.
Can you please explain how did we create this convex hull?
Yeah. Sorry, I didn't get. When you create this convex hull,
So the first step of our algorithm after dividing is to find the convex hull in the
yeah,
half set of points, right?
yeah, half set of
So
points.
my
Yes.
doubt is, sir, how did we create this convex hull?
So that is just recursive procedure. I mean, you have this algorithm, let's say, for constructing convex hull of the large set of points. So you just apply that algorithm on the small set of. I mean, that's what we have been doing for the whole of divide and conquer. That.
Yes, sir. Yes, sir.
So just assume that you have these convex hulls and you want to combine these two to create a big convex hull of the large set of.
Okay, sir. Okay.
Okay. So here we want this lower tangent and upper tangent. These are just the points connecting. Okay. And the main question is, how do you construct these two line segments? Some algorithm for constructing these tangents. Okay. Okay, I guess we are running out of time. So just think about this. How will you construct this lower tangent and upper tangent? Okay, some algorithm. So okay, we'll stop for now. Any questions regarding what we did today?
Sir, I think class is till 9:45.
Yeah, if you have any questions, let me know. Because this is going to take some time, lower tangent and upper tangent. So I don't want to stop in the middle of.
And sir, my doubt was that
Yeah,
how are we representing this context in computer?
yeah. So that someone already suggested that we use a circular linked list. Sorry, doubly linked list, right? So you just store these line segments. Okay. So let's go back here. Yeah. Let's say you have this convex hull here. So A links to B, B links to A. Similarly, B links to C, C links to B, C links to D, and so on. And F links to A, and A links to F.
Yes, sir. Means the IGs are represented by the links, right, sir?
Yeah, that's it.
Yes.
You can't store each and every point on this line segment, and so that is difficult because there are infinitely many points here.
Yes, sir. And so the points are represented by a structure, right? Structure containing x coordinate and y coordinate, right,
Yeah,
sir?
X coordinate and Y coordinate.
Okay, sir. Okay, sir. Yes,
Okay.
sir.
So just think about this. How will you use divide and conquer and get them in
Yes, sir.
conflict?
Yes, sir. Yes, sir.
Okay.
Sir, here can we use the approach that we are having the set of points
Yeah.
and we can construct a circle and increase its radius until all the all the points are enclosed within it, and
Okay.
and just find the polygon that closely that matches the closest with the polygon of that points.
But how do you know that that polygon will be connecting some of these points? So I mean, we don't want any polygon. Otherwise, I'll just draw a big square which contains all these points, and then I'm done. So you have to connect some of these points.
No, sir, no, sir. I am saying that we can find all the points that are closest to the circle, right? Closest to the boundary of the circle, and connect all those points.
Closest to the boundary of the circle. Okay.
And then connect all these points to obtain the polygon. Yes, I was
Okay.
just thinking about it. I'm not sure
Yeah.
if that is the correct approach.
Yeah. No, it might work, but how will you find the points which are closest to the boundary of the circle?
Sir, for that, uh, we can put that point in the equation of the circle.
You can put that point.
In the equation of the circle and
Okay.
find which is giving the lowest answer, which is giving the answer closest to 0. If it is equal to 0, then it is on the circle, and if it is close to 0, then it is nearer to the circle.
If it is
Suppose
close to 0. Okay, so what you're saying is for every point, we will put that in the equation of the circle.
Yes, sir,
And we
right
check
now,
the value.
yes, right now that is the approach. Miss, I need to think about it, sir.
Yeah, you think about it. You have till Thursday. Next class we will discuss.
Okay, sir. Thank you, sir.
Okay. Okay. I think there are no other questions. Okay, there are no other questions. We'll stop this meeting now. See you on Thursday.